Okay, we have the model for the piston we're printing up for the Nelson Brothers here. It was drawn up in CAD. I'll put a picture of that in later. And here we are in our slicing software. This is Cura slicing software. This will take the STL file and make it into G-code for the 3D printer. The 3D printer is going to go on to is a Creality CR10 S5. And it's telling here with the print time, what we're going to do, we're going to print just with a 0.2 millimeter layer height. It's going to say about 11 hours and 10 minutes. We're going to use 47.5 meters of filament. We're using a 1.75 filament. We're going to be printing in PLA, and I'll slice this and then we'll continue over on the 3D printer. Okay, we just started to print the piston here. It's looking at it, it's just over an 11-hour print. Ignore the crappy masking tape on the table. When we do pistons, it seems with the flat face, it always rips the masking tape off, so I just put what's needed. Here's an example of a piston we just printed. This is a slightly bigger one. This one's out of a Waukesha engine. This one, the piston, the bore will clean up at 4 3/4 plus 30 thou. So the piston's just under 5 inches. The piston we're doing is for a 3.5 inch bore. It cleaned up at about 30 thou over. So we'll make the OD on that one about 3 11/16. Okay, we're printing with PLA on this particular piston. All the pistons and castings we do with a foundry, they like PLA, it burns out clean. The bed is preheated on this to 60 degrees and we're printing at 205. I don't know if you ever need the bed that hot, but we've had good luck with it, so I don't bother to change it. Okay, so here we have the 3D printed model for the piston that we are going to get lost PLA for the little Nelson Brother project we're working on. You can see here when it was modeled up, it has the boss on my right hand side here for the set screw. See if I can get in there. There it is. There's just a 1/4 inch set screw to lock the piston pin in. Has the little tip down on the bottom for the center. You can't see in here, but it is here. There's actually a rib underneath the piston bosses. That is printed in there. When we modeled it, we gave about a 1/16 inch on both edges to allow for shrinkage. You can see the original wasn't even faced. We'll probably just give it a quick face. He molds in the just a rough smaller hole for the piston pin, and we'll run a reamer through that to make sure everything's nice and round and square. When we make them, even to allow for shrinkage, we make them about 3/16 bigger, so that gives us plenty of room for an overbore. That way we don't have to worry about putting a sleeve in it, we just overboard it cleans up. Preferably a nominal size, so if rings are easier to get. If not, custom rings can always be either made or bought. And so yeah, that's basically what they'll do at the foundry, is you pay by the tree. Is for a piston like this size, we should be able to get about 6 per tree. You pay for 1 or you pay for 6, so we'll probably end up, we have a couple other projects we're working on for pistons we're going to do as well. With all this stuff going on with this COVID stuff, the lead times are a little bit longer. I'm just guessing, I haven't talked to the foundry yet, but it's probably going to be a couple of months at the earliest before we get these back. But we'll have to go talk to them this week here and see what they say. But yeah, so that's basically making a new piston in a nutshell. The only thing is, what we learned is over when we did these the first times, we didn't have big rads and big fillets in them, and we had issues with sand when they first put the first couple of coats on. So now you can see, with the exception of up in here, and it's such a thin area, I'm not too worried about it. But like down where the piston pin bosses and that are, it needs a decent size one, because if not, then we have issues with sand sticking to it. But yeah, we'll take this into the foundry and see what they say, and when we're done, we'll show how they came out. Bye for now.